Hey, so this will be the last video then. You see I've just blotted out the answers because I think in this case it gives too much away, so I would do that. So we're looking at drawing our differentials, and we did talk about that a wee bit earlier on. Okay, so we've got probably a cubic here, power 3. Yep, the stationary points here and here, and we're going to sketch the graph of g dashed. Now for that one, the easiest thing to do, and I'm actually using a straight line this time, is to try and line up with what's there. Okay, that just will help visualize that a little better. So there's a straight-ish line, and I'll do that as well. Okay, bring this down a bit as well. So first of all, let's think about it. The gradient here is positive because we're going in that direction, aren't we? Positive, 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 and then we get to here, and the gradient is 0, and then it's negative, 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 and then we're at 0 because it's stationary point, and positive, 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 positive all the way along. So for us, we don't want to mark on the zeros because we should know that, okay, well, if this is my differential graph, this is dy by dx by x, so this represents dy by dx. Okay, well, dy by dx is, say up here, it's 5, 4, 3, 2, 1. This is dy by dx is 0. So at this point, I have got dy by dx is 0. At this point, I have got dy by dx is 0, so we're happy with that. The next thing you might want to think about is, okay, well, this was a cubic function, so it's x to the power of 3. If I differentiate that, I end up with something like this, a parabola. So I would imagine that this would look a bit like a parabola. I don't even have to really think about that. All I have to think about is, okay, I've got positive, negative, positive. So in this section in here, before the 0, all of that has to be positive. And in here, after this turning point, all of this, line has to be positive. And in the middle, it has to be negative. It's going to have to go in this zone in here, isn't it? There's all my negative values. We'll just carry that down. Yeah, because this is now -1, -2, -3, etc. So how does my line get from up here to down there to up here? Well, it's going to look something like this, isn't it? And that ticks all my boxes. It's in those zones. It's a parabola. And yeah, positive, negative, positive. So let's just rub out see if we got the right answer. Let's rub that out. Oh, there we go. Fantastic. The only thing that I've not done is I've not specified, the roots, which I could write on as 4 and -2. And I could probably have just drawn it slightly better, where I could say, okay, well, if it's 4 and -2 for the roots, the turning point is bang in the middle there. So what number is bang in the middle between these is going to be 1. If I really wanted to be a hero, I could say the turning point here is going to happen when x is equal to 1 as a wee extra, or just draw it that way. As you can see, that's what they've done. But yeah, make sure you mark on your roots as well. Right, let's go to this one. Curve has got this equation, find the coordinates. So we're going to be using our information to sketch it. So just a slightly more involved process this time. Okay, so let's find our stationary points. So stationary points occur when dy by dx is equal to 0. dy by dx in this case is going to be 6x take away 3x squared. I'll differentiate that. Sorry, I'll factorize that. I'll take out 3x, 2, take away x. So I know I've got stationary points when x is equal to 0 and x is equal to 2. What are the y values for that? That's y to 3x squared take away x cubed. So for x is equal to 0, y is equal to 30 squared cubed. So that's going to be equal to 0. So I've got a turning point at 0, 0. And for x is equal to 2, I've got y is equal to 2 squared take away 2. So that's going to give me 4 is going to give 12. Take away 8. That's going to give me 4. I've got another turning point at 2, 4. So that's me got my 2 turning points. Fantastic. I would quite like to know when I cross the could I do that? Yeah, well, let's look. I could like to find out where I cross the y-axis. So across the y-axis, x is equal to 0. So that's going to be y is equal to 3 times 0 squared, take away 0 cubed. So that's equal to 0. So I know across the y-axis it's 0, 0. So that's my intercept. I could draw in my roots as well. See, so I'll just copy. Let's have a look what I was going to get my roots. I'm going to go over here for the roots. That's for x is equal to 0, isn't it? Sorry, that's when y is equal to 0. I'm saying 0 is equal to 3x squared take away x cubed. I can take out an x squared. That's going to be 3 take away x. I know my roots are when x is equal to 0 and when x is equal to 3. So we're starting to build up a picture now of of the graph. I've got my roots in there. So my roots. I have got my intercept. Is it 0, 0? I've got a turning point here and I've got a turning point here. The only other thing I'd like to work out would be the nature of those turning points. So for the nature, just do a little bit down here. This is why it's 6 marks. It's quite a big question, isn't it? But for the nature, I'm going to do my y double dashed, not f. So I'm going to do d2y by dx squared. So I know my differential was this. Didn't that right? Differential is this. Or just quicker to type it, but anyway. So there's a differential. My double differential, d2y by dx squared, is going to be 6 take away 6x. So let's substitute in my 0 and 2. So when x is equal to 0 and x is equal to 2, what are my natures like? Well, d2y by dx squared is equal to 6 take away 6 times 0. So that's going to give me 6 take away 0, which is 6. And d2y by dx squared, 6 take away 6 times 2. That's going to give me negative 6. So this is a positive number. So d2y by dx squared is greater than 0. So that's going to be a minimum turning point. And d2y by dx squared is less than 0. So that's going to be a maximum turning point. So now we've got enough information, we can start to draw out this bad boy. So let's see, minimum turning point, that one, maximum. So let's start to draw. Let's see, I'll draw my scales in. Let me just pause. Okay, so I have got a turning point at 0, 0, which I said was a minimum. So it's 0, 0, a turning point. It's doing something like this. I said we've got a maximum turning point when x is 2, so that was the 2, 4. So let's go along to 2 and up to 4. That's going to be like a maximum. Put that in. That's 0, 0. I would also say, so I'll just tick these off as I use them. Use that, I've used that. I have used this, and I've used this. We said that the roots were going to be 0 and 3. So that's fine, I've used that. I know that's right there. And this is going to have to cross down here at 3. And I know my y-intercept is 0 because that's where the turning point is. That's fine. And that is me. So now I'll just join it up. So that is going to go down there. This is going to go up here. And this is going to go off forever and ever and ever. If you wanted to double check this, you could always substitute a kind of a big negative number and a big positive number just to check that you end up with a point where you would expect it. So you could put it into the differential and make sure that here you've got a positive gradient, for example, positive is up to you. Try that. And let us just see then. Let's have a look. Let's reveal our answer and check if it's okay. Oh, look at that. Isn't that fantastic? But that is a big question. There's a lot in that. However, what is it really trying to get you to do? It's trying to get you to work out stationary points. Where are they? The x and the y and the nature, which we've been doing. The only other bit I would say is get your roots and then sketch it on. Good.